wanted to tell you that I'm not in space. There's a picture behind me. I wanted to share this picture because I thought it was a very interesting piece of innovation. This is a first in a lifetime view of a spacecraft at 36,000 kilometers with the Earth as a backdrop. This picture was taken from what we call a mission extension vehicle, which is another basically special purpose satellite that docked into the satellite to give it an extended life. And this happened earlier this year, so I thought it would be interesting to show this. But I want to talk a little bit about this new reality of COVID that we're all living in, and that obviously gives us some of those challenges that we just experienced. Aside from all of this, from the network's point of view and from the telecom point of view, what we see is a lot of movement of people away from those urban areas that are really well connected by terrestrial into suburban and rural areas where people live. And this is where we see a lot of the traffic and the backhauling capacity is becoming more and more needed. Increasing also the coverage has been more of a key. And we see that as an example in Germany, where one of the MNOs was fined by the regulator for not meeting their deployment targets. Everything from equipment installation, logistics, everything on this front has suffered in this COVID environment, unfortunately. Of course, there were challenges even before COVID for MNOs and for telcos related to the fact that they're trying to outsource their infrastructure, that there's need to focus more on the core business and to worry more about the decreasing profit margins. So I know that for many people in the audience, you guys are a little bit more removed from the satellite on a day-to-day basis. So I'd like to give you a little bit of flavor on some of the things that satellite is contributing to, and how we think it is and increasingly is becoming a solution to some of those challenges that I mentioned earlier. But that does require some pragmatism and a different business model in the way we do things. In the old days, satellite company just sold raw capacity to mobile operators and to telcos, and they had to kind of worry about how to package it, what to do with it, how to run satellite operations, and then how to make the economics work, which wasn't always easy. So I'm going to give you a couple examples of some creative business models that we have been adopting across multiple Gs, different Gs. So for example, in the 2G world, we work with this company called AMN. It's a company based in Africa, and it's a company that we invested in. Their overall solution is really based on a low-cost approach for the whole thing, from the tower to the solar panel to the satellite capacity that powers that, and it's really powered by a couple dozen of our satellites that are based over the continent. The way this works is that this company has today revenue share deals with MTN and Orange in Africa. So those operators who want to basically deploy to ultra-rural sites without incurring any capex or risk of deployment can do so with a revenue share agreement or even an OpEx model. And today, AMN is operating in 9 countries, has about 1,500 sites. They're reaching over 5 million people in a span of 2 years. And this is really a market that was untapped for the MNOs that is now possible for them to do this. It's a profitable model and a scalable model for MNOs. In the 3G world, we're working with a company in Peru. Actually, we're working with a service provider and an MNO in Peru to deploy 3G to unserved areas, rural areas again. And that's, again, a partnership model and a revenue share model where we are focusing the capacity basically on the areas where the population density it justifies it the most. But we're also working in 4G, in a 4G environment, and I'll give you an example of Japan. We all know that deploying terrestrial infrastructure and fiber to thousands of sites is a really costly matter, and it's also one that is frankly takes a lot of time and is distracting for the MNOs. What we've done in Japan is with SoftBank, we've designed and deployed a fully managed end-to-end hybrid solution that really now is the primary connectivity to 100% of the people that live in this in those rural areas that they're targeting. We have about 4,000 sites and 2.2 gigs And in the first 2 months of COVID, the traffic has more than doubled. But because this hybrid approach, this resilient hybrid approach was there to start with, it allowed really SoftBank to have the flexibility to quickly adapt and respond to the shifting connectivity requirements. And because of that capability of moving traffic between different sites, it allowed them to really oversubscribe the network and to provide bursting capability to all the sites. So dealing with the traffic surges, even the most remote areas. So as the MNOs refine their business models and focus on what they do best, and they're moving away from the infrastructure, we as satellite companies and Intelsat are moving more down the value chain in their direction to offer fully managed services. And this really caters well to the MNOs that either do not have the capability to run satellite operations or just simply don't want to do that because they want to focus elsewhere. So we've launched and are launching in 4 key markets and expanding in 2021. We are also supporting the customers with on-the-ground services to install, maintain, and troubleshoot the network. So it's a full end-to-end solution that makes the economics for the MNOs much better in reaching those rural areas. So we're making it easy, fully managed. We're changing the business model. We're pricing per site as opposed to per megahertz, and it's a very competitive model. So looking at the future, the way we look at it is we think that network flexibility, scalability, and resiliency are going to be more important than ever. And supporting the future growth of the advanced technologies like IoT and 5G will really require hybrid networks. And one example is smart cars that are driving in rural areas. Those will not be able to rely only on terrestrial by itself. And the space-based platform will help also scale in a very cost-effective way by multicasting content directly to a large number of edge servers over wide areas. So we're moving really from a satellite solution or satellite service to a service that is fully integrated into a hybrid terrestrial and satellite solution. And what's very important and what we've been driving at Intelsat is the standardization effort for the non-terrestrial transport for 5G. So the Release 17 for the 3GPP will now include satellite. But we also know that HAPS are coming, and HAPS, for those who don't know them, are high-altitude platform systems, and that's basically balloons and drones and different types of unmanned planes. And so we're engaged today in a POC with MNOs and working on use cases for how HAPS could work, and we've also joined the HAPS Alliance, may be of interest to many people in the audience. Today, the HAPS Alliance includes Google, includes SoftBank, includes AT&T, Ericsson, and Airbus as well. So aside from the many areas of cooperation between satellite and terrestrial that we see, I'd like to leave you with a couple of thoughts and updates. One is on the C-band clearing project. And many of you have heard about this project that is happening in the US to clear the C-band spectrum for 5G. So we have been working with the FCC on this for a while, and the objective is to clear high-quality 280 megahertz of C-band spectrum for usage for 5G in an accelerated way. Of course, we have to do that while protecting the business and the C-band business in media that we serve. We have over 100 million households that are receiving content on C-band, and it's important that those people will retain their services, but also get that 5G spectrum that is really high quality for US MNOs in a fast way. So this is progressing really well, and there's an auction next month on that. The other topic that I wanted to address is some of the innovation that everyone is hearing about in the satellite world. One particular element is the LEO constellations that we hear about, and they're mega projects in these, and they will populate space with thousands of satellites, but they have a lot of challenges. It's important to note those challenges. First of all, those constellations need a return on investment for the big investments that are being spent, the billions of dollars that are being spent on them. Unfortunately for those constellations, the whole constellation has to be up in space before they start monetizing and then they have a short period of time to do that because the lifetime of those satellites is very short. Aside from this, the user terminals that are needed to connect with those satellites, because everything is moving so fast, are flat panel antennas, and today there's no technology that can do that at volumes and price points that make sense. Of course, not having inter-satellite links on the satellites also pose a lot of regulatory challenges. So there's a lot of challenges, with those constellations that would, remains to be seen how they develop in the coming few years. On the other hand, on the traditional geospace that you guys are probably most familiar with, there's also a lot of innovation, from software-defined satellites to ground networks that are 3GPP compatible and hybrid, and this is the focus for the future. Standardization is the focus for us for the future. So, I just like to leave you with imagination of the opportunities ahead. Standards and partnerships are key to make this work. There's a lot of opportunities in a ubiquitous and hybrid connected world, and this is what we're working on, and we will continue doing that, continue driving those things. Thank you very much.